Okay, here comes the second conjecture about triangles. For this one, I need you to remember a couple of things from previous grades. One is what it means for two shapes to be similar. That means that they have the exact same shape, same number of sides, same angles at every vertex, but they're different sizes. And compare that to being congruent, which means they're the exact same shape and size. Okay, so I drew a triangle here and I'm going to find the midpoints of side AB and the midpoint of side AC. So let's say it's about there for AB and about there for AC. Now that's the midpoint, so this side, that piece of that side is the same length as the top piece of that side, and these two are the same length because they're midpoints. And I'm just going to connect those with a line. Okay, now my conjecture is, let's label this D and this one E. My conjecture is that line segment DE that I just created is 1/2 the size of the line segment BC. And can I show you that that's true? Can I prove that that's true? All right. Let me try. So what I want to say is that this triangle ADE, the smaller one, is similar to the bigger triangle ABC, but half its size. Okay, and if that's true, then I think I've got what I want. So I can know that two triangles are similar to each other if the sides, if I can go one side, a shared angle, and the other side, and the ratio between the length for AB and AD is the same as the ratio between the length for AC and AE. That would make those triangles similar. Okay, you might have to take that kind of on a leap of faith. I can see that the length for A to B, let's say it's 2, okay, give it a length, it's twice as long anyway as the length from A to D. In this case, it would be 1. Why is it twice as long? Because D was the midpoint. Okay, whatever length A to D is, the length from A to B is twice that. And that's also true on the other side where I made E the midpoint for AC. The length from A to E is 1/2 the length from A to C, or AC is twice as long as AE. So these two triangles, they have corresponding sides that are in the same ratio, and they share a common angle. So these two triangles are similar. Triangle ABC is similar to triangle ADE, and ABC is twice as big as ADE. And since they're similar triangles, that means that the length from A to B is twice as long as the length from A to D. The length from A to C is twice as long as the length from A to E. And that would also mean that the length from D to E, the length from B to C, is twice as long as the length from D to E. So the length of BC is twice as long as the length from D to E. All right, so I now know no matter what triangle I draw, I can always connect the midpoints, and that line will be half as long as the third side of the triangle.